Practice problem 3 tells us that a biologist measured the length and weight of 15 fish of the same species. The results are shown on the scatter plot. We see the scatter plot here where the length, or the length in inches, is on the y-axis, and we see the weight in pounds is on the x-axis. What I notice about the data as we start moving to the right, as we start getting fish that weigh more, naturally, as we would expect, the length has to actually increase because the heavier the fish is, it's probably a longer or a bigger fish. So we see as we move to the right, the graph, the scatter plot data is moving up as well. By the time we get up here, we see that by the time a fish weighs 5 pounds, it's likely to be 20 or 25 inches in length. And these fish that only weigh 1 or 2 pounds are just 5 to 10 inches in length. So we see that it's a positive association. As x gets bigger, y gets bigger. And it also tends to follow a straight line pattern. So even though they don't fit perfectly on a line, we would still call it a linear association. So the best distractor is probably the positive nonlinear one, because some of you might say it's not a perfectly straight line, but if a line generally maps the trend, then we are going to call it a linear trend, and this is a positive linear trend because x and y get bigger together in this real-world situation.